All right, part 2 of 11.2 is still dealing with categorical variables, and we're looking at one population of interest now. So we're looking to see if there's a relationship between two variables. So our null hypothesis is that there's no association between two categorical variables in the population of interest, whereas the alternative hypothesis is that there is an association. So what we do is a chi-square test for independence. So using a two-way table, we will still select the chi-square test from our list of tests. This test is used when we suspect the variables may not be independent. So knowing one variable changes the probability of the other. So, for example, knowing the tattoo status of someone will change the probabilities for their hepatitis C status. So we would test the null hypothesis that it's not true. We would test the null hypothesis that there's not an association. So what's different? The hypotheses. Technically, the way we would calculate the expected values is a little bit different. It's based upon conditional probabilities, but it actually ends up working out to be the same way. So here are your basic rules for your null and alternative hypotheses. So let's look at an example. Pause and take a moment to read. Okay, so there are two-way tables here, one with the observed counts, and so we need to find the expected counts. And again, you're going to do the find the expected counts the exact same way we just did in the last video. So pause and find those expected counts. Okay, so go ahead and now verify that you have the correct answers. Okay, so part B. Do the data provide convincing evidence of an association between anger level and heart disease in the population of interest? So of course we go into the state plan do conclude. So go ahead and pause for a moment and write down what you think the state should be. Our null hypothesis should be that there is no association between anger level and heart disease status in the population of people with normal blood pressure. So therefore, the alternative hypothesis is that there is an association. So now think about the plan. Pause. We're going to go ahead and do a chi-square test. And actually, I could be more specific with that. And say do a chi-square test for independence with a degree of freedom of 2. Again, this is going to be the number of rows minus 1 times the number of columns minus 1, so we get 2 times 1 is 2 there. We're going to use alpha is 0.05, and of course we do this if conditions are met. Conditions, we still need to check random. We need to check the 10% rule. And then we need to make sure that our expected values are all greater than 5, and indeed they are. Again, just to reiterate, please make sure that you do not just say that the expected values are greater than 5 and you don't show them. You need to show the expected values. Okay, now go ahead and do. You're going to do this in your calculator and write down anything that you need to. So pause and do that. Okay, so when you do that, you should get chi-square 16.077 with a p-value of 0.00032. Again, just to kind of remind you that in order to get that, you did have to use the matrices in your calculator. So matrix A would be the observed, and matrix B would be the expected. So conclude. Because the p-value of 0.00032 is less than our default alpha was 0.05, we reject the null hypothesis. We have convincing evidence of an association between the anger level and heart disease status in the population of people with normal blood pressure. Can we conclude that proneness to anger causes heart disease? Think about that for a moment. Pause and think about that. No, this was actually an observational study and not an experiment, so we cannot draw causation. All right, go ahead and take a moment to read this next example. Okay, notice it says assume the conditions are met. We're just going to kind of look at some reasoning. So the first one says explain, or part A here says explain why a chi-square test for independence and not a chi-square test for homogeneity should be used in this setting. So pause for a second and think about the difference between those two tests and why we should be testing for independence here. So, the data were produced using a single random sample of college students who were then classified by gender and whether or not they had a lingering fright symptoms. So, it is one random sample, and they're looking at two different variables. So, because it's from one population, that's why you're looking at the test for independence. The chi-square test for homogeneity requires independent random samples from each population. So, part B, state an appropriate pair of hypotheses for researchers to test in this setting. So we already talked about it should look like an independence test. So pause and write down your null and alternative hypotheses. Okay, it should look something like this. The null hypothesis, there's no association between gender and ongoing fright symptoms in the population of college students. Then the alternative hypothesis is that there is an association. Part C. Which cell contributes most to the chi-square statistic? In what way does this cell differ from what the null hypothesis suggests? So pause for a second and just look at the data and see what you think contributes most to the chi-square statistic. So again, it says the expected counts are printed below the observed counts, and then you have the chi-square contributions below that. Notice, men who admit to having lingering fright symptoms account for the largest component of the chi-square statistic. So they contribute 1.883 of the total chi-square statistic 4.028. Notice that far fewer men in the sample admitted to fright symptoms, 7, than we would expect if H0 were true, and the expected value would be the 11.69. That's how you get the chi-square statistic of 1.883 that is so large. This is where you get your chi-square statistic if you were wondering. Okay. Part D. Interpret the p-value in context. What conclusion would you draw at a 0.01 alpha? Pause. Okay, so notice that our p-value here is 0.045. So if you didn't find that, that's where you find it right here. So if gender and ongoing fright symptoms really are independent in the population of interest, there is a 0.045 chance of obtaining a random sample of 117 students that gives a chi-square statistic of 4.028 or higher. Because the p-value, 0.045, is greater than 0.01, we would fail to reject H0. We do not have convincing evidence that there is an association between gender and fright symptoms in the population of college students. So notice we did two things here. We had to interpret the p-value and basically draw a conclusion as a comparison to the alpha is 0.01. Pause if you need to get that done. Okay, so we just have a box here that just kind of sums up everything for the chi-square test for independence, which is in your note packet.